Hello, Math 3 students. I hope you had a good weekend. Unfortunately, I am not here to be with you today, so I made this video in order to deliver you some content, and then if need be, I can kind of clarify questions and cover this in tomorrow's lesson. We'll also expand what I'm gonna talk about today in tomorrow's lesson. Today we are going to talk about simplifying radical expressions, and our objective is just that, to simplify these radical expressions. Kind of touching on your prior knowledge, if I asked you what 8 to the power of 1/3 is, you would remember that here, right, if I'm taking, if I have a power that is a fraction, I am really taking the cubic root of this. It would be kind of the same thing if I asked you what's 4 to the 1/2 power, right? This is just the square root of 4, which is 2. So here in our prior knowledge, 8 to the 1/3 power, really what this is asking is they want us to take the cubic root of 8, which is 2. So kind of the concept for simplifying radical expressions is that we are kind of going to perform some algebraic magic using all of these powers properties. And I guess here we have this chart in our notes that says for all non-zero real numbers a and b and rational numbers m and n, these exist. So if I have the product of powers property, this says to multiply powers with the same base, we add the exponents. So notice here in this example that I have the same base and I'm multiplying it. So to solve this, I just add the exponents. I add 1/2 plus 3/2, well, that gives me 4/2, which is just 2, and 12 to the second power is 144. The same thing holds with variables. So if we have variables, it holds. The quotient of powers property, this says to divide powers with the same base. To divide with the same base, we subtract the exponents. So the same idea as when we multiply with the same base that we add, well, here we subtract. So if I have the same base, 125 to the 2/3 power and 125 to the 1/3 power, I'm going to go ahead and subtract these values. So 125 to the 2/3 minus 1/3, that gives me 125 to the 1/3 power, which is 5. Again, same thing holds here for variables. The next thing we want to talk about, which this way may be familiar from Math 2, is the power of a power property. Here this says to raise one power to another, we multiply the exponents. So 8 to the power of 2/3 raised to the power of 3, well, I multiply these guys, right? And 2/3 times 3, my 3's cancel out, and I get 8 squared, which is just 64. The power of a product property. The same idea, if I have two numbers that are multiplying, right, and that is raised to a power, to an exponent, well, I just distribute this exponent into each term on the inside. Same idea is if I was dividing here for a quotient. So 16 to the 1/4 divided by 81 to the 1/4. So we can go ahead and distribute that exponent into each term, and then we can solve. Now, the one that is pretty tricky for people is when I have negative exponents. Now this says when a base has a negative exponent, write the reciprocal of the power and change the sign of the exponent. So here I have 2 to the 1/3. Well, I'm going to flip this. I'm going to make the reciprocal. So instead of 2 to the negative 1/3 over 1, it's now 1 to the 2/3. And notice the exponent now becomes positive. So now I have 1 over 2 to the 3rd power, which is 8. Actually, should be 1 over 8. So please edit that. Add that guy in there. I don't know what happened here. 1 over 8. Okay? So we're going to go through some examples, and then we'll have some practice. If at any time you are confused, feel free to rewind the video, pause the video, and kind of look at the content again. So here are our first two examples. Please write these down inside your notes. numbers 1 and 2. And here I have 125 to the 4/3 power. So since I have a power, I'm going to distribute this into my base. So I now have 125 to the 4/3 power. Well, when it's written like a fraction, really, I'm taking the root of this. So I want the cubic root of 125, and then I'm going to raise that to the power of 4. Well, the cubic root of 125 is 5, right? That's 5 times 5 times 5 is 125. And then we want to take the 4th power of that. So now I have 5 raised to the 4th, and this happens to be 625. Here I have quotient. I have a quotient, 81 over 16, and I want to distribute the negative 3/4 into each term. So kind of hitting double ideas here. So first I'm going to distribute in my exponent. So I have 81 to the negative 3/4 over 16 to the negative 3/4. Notice that I have negatives on these, so what we end up doing is we just end up flipping. This guy here, the 81 to the negative 3/4, is going to go into the bottom. And the 16 to the negative 3/4 is going to move into the top of the fraction. So kind of the idea is if you have a negative, you're going to move it from the numerator to the denominator, or from the denominator up to the numerator. So let me rewrite this now, and now I have 16, the 4th root of 16 to the 3rd power, divided by the 4th root of 81 raised to the 3rd power. So the 4th root of 16 is 2. The 4th root of 81 is 3. And I have those raised to the 3rd power. So this ends up being 2 cubed is 8. 3 cubed is 27. And that is my answer here. Okay, at this point, I would like you to go ahead and pause the video. Let me see if I can pop this up without it. Oh, it's going to show. I want you to pause the video and try this example on your own, please. Go ahead and pause now. Okay, hopefully you tried this one. Working through this, you should have gotten to the answer 4 over 9. I distribute the 2/5 to each, the numerator and the denominator. I take the 5th root of each term and then square, and I end up with 4/9. If you can reduce, go ahead and reduce. Here we cannot. The next example, please pause and try this one on your own. Okay, hopefully you have tried this guy and distributed the negative 2/3. After you distribute the negative 2/3, the 512 goes into the bottom, right, with the power of 2/3. This becomes positive. I take the cubic root of 512, and then I square it. So 8 squared gives me 1 over 64. Another way that you can do that is the negative can stay with the power on the outside. You can take the cubic root of 512 to get 8, and then 8 to the negative 2nd becomes 1 over 8 squared, which is 1 over 64. For our next two examples, examples 3 and 4, inside your notes, notice here we have more negative exponents. So I'm just going to distribute in my negative exponent, giving me 16 to the negative 1/2 power. And when I get this, this go ahead and it moves into my denominator. So now I take the reciprocal and I change the power into a positive. So 16 to the power of 1/2. Sorry, 1 over 16 to the power of 1/2. And I take the square root, right? 1/2 is the square root. So 1 over root 16, which ends up being 1 over 4. So that would be my final answer. Here, same idea. I'm going to take 1 to the negative 1/3 power over 8 to the negative 1/3 power. And since I have these negatives, I'm going to go ahead and end up taking the reciprocal and change the negative to a positive. So 8 to the 1/3 power over 1 to the 1/3 power. Really, the cubic root of 1, right, is 1. and I have 8, the cubic root of 8, which is just 2. So 2 over 1, which ends up being 2. My answer is 2. This is very algebra heavy, so if anytime it's not making sense, again, rewind, pause, go back, and kind of check each step against your notes and the products and the properties that are going on. Here we have more practice, so please pause the video and try this one. You can do this on whiteboards or on separate binder paper if you wish. Okay, hopefully you've tried this. And after distributing the negative 1/3, we take the reciprocal, we change the negative to a positive, and we take the cubic root, we get 1 over 3. I have 1 over 25 to the negative 1/2. Please pause the video and try this one on your whiteboard or on separate binder paper. Okay, and after doing this, you should have gotten 5. Okay, couple next examples are going to touch on the product of powers property and quotient of powers property. So here, notice I have the same base, right? They're both 8, and I want to evaluate this. Well, I have the same base with exponents, so the quotient of power property says I can take 8 to the power of 3/6 and subtract the value of the second exponent with the same base. So 8 to the 3/6 minus 5/6, well, I can subtract and add only if I have the same base. So here, sorry, the same denominator. So here I have 8, and they both have a denominator of 6, so I'm in business. So 3 minus 5, that is negative 2 over 6. And we can end up reducing this guy. So 8 to the negative 1/3, right? I reduced by 2. And when I have a negative, I take the reciprocal, so 1 over 8 to the 1/3. Well, 1/3 is just the cubic root of 8. And the cubic root of 8 is 2. So 1/2 is my answer for this guy. Next example, I have 25 to the 3/5 power times 25 to the 7/5 power. So instead of doing all this and computing these values, I see I have the same base. So what I'm going to do is I'm going to take 25 and I'm going to add these fractions. It still works too. If they were whole numbers, you would add them, right? So I add these guys, and again they have the same base, or sorry, the same denominator, so I can add them, and this gives me 25 to the power of 10 over 5, and that reduces to, or simplifies to 2. 25 to the second power. Okay, and if I bust out my calculator and I square that, this gives me 625. 625. Okay? All right. These examples are just the same ideas and principles, but with variables. So these are in your notes. I believe that was 5, 6, so this would be what, 7, 8, and 9. I have about, I don't know, 50 seconds left, so I'm going to squeeze this in. So on these guys, same base, I'm going to add them. So x to the 2/3 plus 1/2. Notice not the same base, so I have to go ahead and simplify this. Okay, and when I do this, I should get, so I'm going to scoot back, I should get 2/3 plus 1/2, and this will give me x, and I'm going to find a common denominator, which is going to be 6, so I'm going to get 4 over 6 plus 3 over 6, and when I add these, I get x to the 7 over 6. Okay, that's all for this video. I'm going to make another one.